All right, with that, the recording's going. We're going to go ahead and get started. Gentlemen, Tom, Alex, and Lucas, thank you for being with us tonight. We got all kinds of stuff to talk about and do. And we're going to finish tonight. I wrote down on my notes, a few weeks ago, I had posted an assignment of what do you need help with? What diagnostics can I help you with? And so we're going to look at one of those diags tonight. That's how we're going to finish our class and see if we can move forward on some stuff to diagnose. It will certainly give us some stuff to talk about, which is really what it's all about. So before I jump into tonight's presentation, what I would like to do is look at the calendar, and I've been working on getting all your assignments posted. I don't have everything completed, but I have the majority of stuff posted up on Canvas for you guys to start working on and looking at, which is pretty exciting. So I'm going to go over here to the course calendar, because the way this popped up is I wanted to have some things launch last week, and they didn't launch until I looked again at it and realized I didn't click the launch button. So they launched a little late, but they're relatively easy things. My goal is to give you just like one or two little things to work on each week as we round out this class. So let's look at those. And so with that, I'm going to click on the calendar, and we'll get stuff going. All right. So what you'll see here, this looks worse than maybe it is. I moved this what diagnostics that do you need. In fact, I'm going to push this back because I want people to keep, if they have a diagnostic problem that comes in, I want them to keep working on this. And I realized when I looked at it, it was supposed to be a discussion. And then when I launched it, it did not launch as a discussion. So anyways, we'll finish our class tonight talking about this stuff right here. But what I want to do before then is get going on the current discussion. So what I would say is don't worry about this one right now. I'm going to extend it out. In fact, let's do that right now. I'm going to leave my student view real fast, and we're going to extend this out because I want folks to be able to continue to post things on there if they have a new problem that comes up on their car, something like this. We'll push this out. Okay, there we go. All right, let's go back to that course calendar, and I'll put it back in student view so it doesn't look quite so messy. So course calendar, go. And so we have a little quiz this week, and it's really about stuff that we've talked about previously. There's some generic Obd2 stuff. In fact, you see some of the generic Obd2 modes on there. It says select the most correct answer for each question, right? Just like you would do on any ASE test. And I'm going to go ahead and click on this thing and open it up. It's only 5 questions, and you'll see it's pretty straightforward stuff, right? Like, when did we start Obd2? What year was that started? The check engine light's on. What does that mean? What does DTC stand for? So this will only take you a few minutes to do. So not too bad. It's all stuff we've talked about in previous class sessions. Okay, so with that, I'm going to go back to the calendar. We've looked at that. I don't think that one will be too hard for you guys, especially since you three have been here for a lot of our class sessions. So I think that'll be pretty easy for you. This one's going to be a little bit more challenging, and so I want to talk about this one. Getting used to normal data. To be honest with you, it took me quite a while to get used to looking at the data coming off of cars and and to know like, well, did that look right or did that look wrong? Like, what's it supposed to look like? And now, you know, I can look at stuff and right away I can identify, oh, that doesn't seem right, or that's working how it should. And, you know, it takes a while to do this. So my goal with this assignment is to help you guys, like, help shorten your learning curve as far as looking at data and seeing what jumps out at you. So with that, there's different ways to figure this out. You can look it up online, like Shotkey Pro. You can look it up on the internet. Sometimes forums will get used. Sometimes there's great resources on sites like the International Automotive Technicians Network, IATN. CDX has stuff. But the idea is that we're going to do a discussion thread and kind of post some stuff. So what I want you to do is just grab one PID, one parameter, right? So it could be, what would a bank one sensor, or what would an oxygen sensor, bank one, sensor one, what would its range be? Or what would be a sensor two range be? What about throttle position, or intake manifold pressure, MAP sensor, if you will, RPM, short-term fuel trim or long-term fuel trim. So I put that up there to kind of give you an idea of some PIDs, but you could take something off of your scanner too, like throttle position sensor or accelerator pedal position sensor. If you're working on a newer car that is throttle by wire, it could be just, you know, anything, intake air, temperature. So anyways, pick one PID. And try to figure out, well, what should it look like? Okay, so what should it look like at cold startup? And that, you know, depending on what you pick, there might be no difference at all, right? Like if it's a mass airflow sensor, there might be no difference between a cold startup and a hot idle, but there would definitely be a difference between hot idle and normal driving conditions, right? So you're trying to put on, like, these are known good values. Now, one of the things that I did in the industry quite a bit is I would take recordings, and different scan tools call those different things. Some scan tools would call them snapshots. The old Snap-on scanner, they called it a movie. But I would take these snapshots or movie files and I would save them. And when a new car came in the shop that I hadn't worked on before, so it didn't have to be new, it could be 2 or 3 years old, but it just happened to be a car that I had never worked on and I had never scanned before. If I got a chance, maybe it's in the shop for an oil change or an alignment or something, I would grab that car, I'd throw my scanner on it, and I'd take a quick recording, at least at like idle and revved up to 2,500. If I could drive it around the block, I might do that. But I would take a quick data recording and I'd save it with the year, make, model of car. And then what I had is I had a recording of known good values. Okay. And that really will help shorten your learning curve, because what will happen is you'll get a car coming to you that's messed up and it's not running right. And then you're trying to look at the data and try to figure out, well, what's weird and what's normal. Well, if you have a recording of these are the normal data parameters, then you have something to compare it to. Okay, so, but the idea with this assignment is to get you used to some stuff on what's normal. So I did an example here. Oh, and I also want you to look at, like, what's the range of that particular PID, that particular sensor, right? So if it's a mass airflow sensor, you know, the range might be from like idle to wide open throttle, or a throttle position sensor between closed throttle and wide open. A temperature sensor would be from full cold to full hot, and kind of everything, you know, in between there. You know, what will be the range from one extreme to the other is what the last part. So it's, what is it cold? You know, you start up the engine and it's cold. What is it when it's warmed up and now it's just idling? And then what is it when you're normally cruising around? And then lastly, like, what's the range from one extreme to the other? What's the range from the low end of that sensor to the high end of that sensor or that data PID, right? So I tried to give you an example, and I probably went a little bit over the top on this, but you know, because I put in a little description of what it is. So engine coolant temperature sensors, or ECTs, they're a negative temperature coefficient on most vehicles, meaning that their resistance gets to be less. It goes down the hotter it gets. But anyways, of course, it's screwed into the engine coolant passages. They usually have 2 wires. Yeah, like I said, I went kind of over the top so that you could kind of get an idea of, you know, what this sensor is, how it works. But here's the nitty gritty. This is really what you want to do is okay, on cold startup, you know, what should it be? Well, you know, it depends on how cold it is outside, right? So that was kind of a hard one. So if you know, this morning maybe you got out to your car and it might have been, I don't know, 50 degrees, 60 degrees, right? But back in December, it might have been 30 degrees. And of course, if you lived up in Tahoe, maybe it's 15 or 20 degrees, right? So that kind of depends. Here's my tip though. So you can look at this as one of the tech tips of tonight. Compare this to your intake air temperature sensor. So when you first start your car, okay, key on, engine off, you just fired it up. Notice like right here, the engine coolant temperature sensor is 68. In fact, I'll highlight that. So engine coolant temperature is 68 degrees. Intake air temperature is also 68 degrees. That's how it should be. These two should be pretty well synced up within a couple degrees or so between intake air and engine coolant temp when you first start your car and everything is cold and it's been stabilized overnight, if you will, okay? Even if you live in Arizona and it only cooled off to, you know, 95 degrees that night, when you first walked out to your car first thing in the morning, both of those sensors should then say 95 degrees, okay? So once you start it up, so this would be a good example right here of a cold startup. Now on hot idle, that's what I got going on right here, because you can see now the coolant temperature's 214 degrees, but the intake air temperature, it's gone up some. It's gone up from 68, but it's still only 77. So it went up a little bit, but not nearly as much as the coolant temp. And so I have their, you know, hot idle. You know, it depends on what the thermostat is on the car. Most cars are going to be 180 to 220, somewhere in that range. You might have a sports car or a truck that's got the heavy duty towing package that maybe is, you know, 170, 175. Usually it's going to be something above 160. Okay. Normal driving conditions, again, are about the same, 180 to 220. And the full range on that, like if the sensor was full cold or unplugged, would be like negative 40 to 40 degrees or 30 degrees. And they usually will peg somewhere between 260 and some will go clear up to 300 degrees. But that's pretty typical. And then I did kind of like a bonus thing. Like right now you can see it shows you the temperature, but some scanners will also show you the voltage on the sensor, which is nice. And I know some of you guys are in the meter class. So if you plugged in your multimeter and you back probed it and you were measuring voltage, well, what would you measure? Somewhere around close to 5 volts when it's cold. So I'll do that in blue. Somewhere close to 5 volts when it's cold, and then usually somewhere less than a half a volt when it's full hot. So anyways, I kind of went over the top, but the idea is that you just give me some parameters. You pick a sensor, pick a data PID, give me some parameters, and then what we can do is we can look at everybody's you can look at everybody's responses. And so Zach did a great job already, posted one on engine RPM. you know, like at the end of this, we should have a full description of a lot of the data PIDs. And so you'll know, have a pretty good idea of these are known good values. This is what I'm looking for. Okay. All right. And then, you know, if you're lucky enough to have a car that's not messed up, like you have a car, it runs perfectly, no check engine light, you know, you can basically just take your scanner, right? Take your OBD interface and, you know, hook it up and look at the data. What is it at cold startup? What is it at a hot idle? And then drive it around and write down what you see. So you could use your car to kind of build that database as well. Okay. And that's kind of part of the idea of this as well, is to get you, you know, looking at scan data and figuring out, okay, what does normal look like? And so that, you know, abnormal data, stuff that's not working correctly, jumps out at you. Okay. And there'll be general trends like Zach did engine RPM. Okay. Well, you know, what you should find is that engine RPM, throttle position, airflow, manifold pressure, all those things should move together, right? So as you open up the throttle, the RPM follows it, right? And the airflow follows it. So those things should all move in unison. Okay. So you have a little quiz due this Friday, 5 questions, not a big deal. It's all stuff we've talked about. And you have to pick a PID and describe it like I've done right here. Okay. And you know, like I said, at the end of this, we should have a pretty good list of what different parameters look like. Okay. So that's what we want to work on for this week. Hopefully that makes sense for you guys. Does anybody have any questions on that? All right. No question. I'm going to take your silence as you're doing okay. But if you have a question or it comes up, don't, you know, you could type it out in the chat, and you know, we'll address it. So what I'm going to do is I'm going to change my screen share to tonight's presentation. It's on Obd2 test modes. And you know, we've talked a lot about these, but I really want to go into the specifics and talk about the ones that we haven't gone over. Okay, so pretty excited about this. So what I'm going to do is get this going. Oh, I see something up in the chat. All right. So get the slideshow going. I'll change the screen share again. There it is. Boom. Okay. Yeah. My goal is to try to make these assignments pretty straightforward for you guys. So each week now, basically from now on till the end of the semester on our class, each week you'll have a couple little assignments due for this course. By themselves, each one shouldn't take you that much time. But what I would say is you know, look at them. And I've gotten the ones for next week. They're already on there and posted. They should be on the calendar and ready to go. And the ones for the week after that are ready to go. And I think even the week after that, I have at least have 2 weeks ready to go. So here's what I would recommend, guys. If you're driving around, look at those assignments and go, okay, I have one where I got to take some recordings. Well, while you're driving around, you know, grab your scan tool and take some recordings. Like, you know, if you're on your lunch break or you got a little bit of time to kill, it'll take just a few minutes of scanning some stuff to get these assignments done, and take some screenshots with your cell phone. You could take a video, but for most of the stuff, it's just a matter of taking screenshots with your phone. Okay. So Obd2 modes, I threw this up on the screen. This would be an example of an older generic scan tool that shows that this one has 9 different modes. Now, these days, there's actually 10 modes. But let's take a step back for a minute. Last week, we went over an 8-step scan tool involved diagnostic process. And I said, hey, don't forget that scan tool, it doesn't replace your multimeter or an oscilloscope. It's one of the tools in your toolbox that's a powerful tool that you definitely need if you're working on modern cars, but it doesn't do everything for you, right? It certainly doesn't replace you as the technician and figuring things out, right? And so last week we went over the verify the complaint, pull the codes, pull the freeze frame, and we're gonna jump back into that tonight, okay? But before we do that, we're gonna then finish up the rest of the Obd2 modes. So moving right along, last week another thing we talked about was how we have the front door, back door concept, where our sensors are front door information, right? And our scan tool is backdoor information. So always forget, or net, I should say, not always forget, but never forget that the scan tool is interpreted information, and sometimes scan tools can lie to you. Here's another analogy. Another way to look at this is that scanners are more general directional tools, kind of like a compass here. They give you the general direction of where to go, but ultimately to get that final diagnosis, 9 times out of 10, you're going to have to break out that multimeter and measure voltages, or you might need to get a compression tester out and measure the engine's compression, or you're going to need some other tools to actually pinpoint the cause. And so those other tools like an oscilloscope or a DVOM, that's more like your GPS that pinpoints exactly what the problem is and what do you need to replace, okay? But you use both of these things together to figure out what's wrong with the vehicle. Okay, and then one more thing about the front door, back door. Don't forget that all your input sensors, like we were going over with those different data PIDs and stuff, all the input sensors, things like your mass airflow sensor or MAF, your engine coolant temperature sensor or ECT, those are all front door things. In this case, I have an optical RPM sensor in a distributor. That would be a front door item. It's an input sensor. And remember, we also have talked a little bit about the hierarchy of sensors, like what's the most important one. This guy right here tells the engine RPM. It tells the computer, I should say, it tells the computer RPM. And so without that, the computer would never know that the engine's turning. Well, if the engine's not turning, there's no reason to fire the spark plugs or turn on the fuel injectors. And so that's your very most important sensor, is your RPM or crank sensor. And that crank sensor, it's kind of a misnomer because it could be located in the distributor. It could be located on the crankshaft. It could be located, driven off the camshaft and do both cam and crank off of that. So anyways, that RPM is super important, because if it's not there, there's no reason for the computer to do anything else. If your crankshaft position sensor takes a dump when you're driving down the road, you're stuck on the side of the road. All right. And again, those sensors are front door information. Okay, the other thing we went into a little bit last week, we just scratched the surface of it, is generic Obd2 scanners like we're using with our cell phone apps and little interfaces, versus manufacturer-specific tools, which are much more powerful. They have a lot more bi-directional controls and stuff, but sometimes they can lie to you. Sometimes there's some false data. The generic tools are going to be very focused on emissions. And so if your goal is to get ready for a smog check, they work really good. So we're going to now take this to the next level, because it's not just generic tools versus manufacturer specific tools, but there's also what I would consider a do-it-yourselfer tool, like what these little interfaces are with our cell phone apps. They're more like a do-it-yourself type of non-professional tool. And then there are professional tools that are made by the aftermarket, made by OTC, or Snap-on, but they are made for the service professional. And there is a difference in those. In fact, we're going to look at that. So this on the screen, this is the Solus Ultra. Okay. So it's Snap-on's, I would say it's like their mid-grade professional scan tool. And it's a nice tool. New, I don't know what that thing costs. It's at least $3,000 to buy one of those brand new. You could probably buy a used one for cheaper, and a lot of times you can get them on, you know, some type of deal that Snap-on has going on. That tool is just a scanner, but it has the ability to simulate the factory tool in some cases, and of course do our Obd2 global stuff. So on that icon right there, if you clicked it on that mode where it says scanner, that's where it's going to try to simulate the factory tool. So the scanner mode here, I'll get my text tool going. The scanner mode is going to be like the OEM tool as much as it can be. Okay. It's not going to still be able to do everything that the factory tool could do, but it's going to do a lot more of those features. It's going to have things called bi-directional controls. What does that mean? I can have the tool control the car, meaning that I could have the scan tool. It could possibly change the idle speed, rev it up and down. You could maybe tap into a body control module and honk the horn, or turn the headlights on, turn on and off the fuel pump. You could turn fuel injectors on and off possibly and do a power balance on the car. So whenever I'm using the scan tool to make the car run a certain way, that's a bi-directional control. Okay. Features like that are going to be found on a professional based tool that's going to be more expensive, and they're going to be on that tool's kind of scanner mode where it's simulating the OEM tool. Okay. Now, this tool has another icon here. And that other icon is, if I can get it here, the Obd2 Obd2. Well, what that is your global, or what I'll call your generic scanner. That's what you're getting right here. Okay. That's where we're going to get the 10 modes that we're going to talk about tonight. All right. Well, let me check out the chat real quick. So yeah, the question is in the scanner mode, and so let me clear out these drawings and let's go back. So in the scanner mode, yeah, it's like the factory tool. Is it going to do everything the factory tool is going to do? No, not really, because the factory tool, like, you know, there's always a reason why the factory is going to have the best tool, right? The guys at the dealership, they're going to have the tool that does everything that that car could possibly do, right? So it's not going to be as good as that, but it's going to be a lot better than our little interfaces can do. There's going to be things that you can do with the tool. You could maybe do some coding. You're usually not going to be able to do programming, but you're going to be able to do some coding. You're going to be able to do bi-directional controls. Also, what Snap-on has in this mode, their kind of claim to fame is a software built into the tool under this mode called Troubleshooter. Well, what's Troubleshooter? Troubleshooter equals a whole bunch of tips and procedures and stuff. I'm going to put quick fixes. The idea with the Snap-on tool is Snap-on had, they wanted their one tool to hook up to a lot of different cars and be able to communicate with those cars. And so they're kind of aimed for that guy or gal that works at an independent shop that's working on Chevys and Fords and Toyotas and Hondas. And so, if you're somebody that has to work on a lot of different types of cars, you don't necessarily see the same car over and over and over again like somebody at the dealership does. So you don't get those pattern failures. When you work at a dealership, and let's say you're working at a Toyota dealer and you've had 5 Camrys all come in for the same code, by the time you're on your 5th one, you're like, oh, I know what it is because the other 4 were this, and it's probably the same thing. But in the aftermarket, right, if you have your own independent repair shop, or I have some students that are mobile repair techs, like you may not see the same cars over and over enough. So what was nice about Troubleshooter is what Snap-on would do is they would offer technicians basically money to write in service tips and procedures, and they would write those into Snap-on, and then Snap-on would put all those tips into this scanner function of their tool, and you could use Troubleshooter to help you figure out what was wrong with the car. And I'll tell you that Troubleshooter several times made me look like an absolute hero. People were like, how'd you know to do that? And it's like, oh, I just looked at the Troubleshooter. But hey, you don't, and that point in my career, I didn't tell them that I wanted them to think, man, this guy's really, really smart. And so I'm like, oh yeah, I just knew it, so that's some of the types of features that you're going to get with a professional tool versus a do-it-yourselfer tool. But obviously that tool costs thousands of dollars more than our little interfaces cost, right? And there's still a lot of diagnostics that we can do with one of these. And so that's what we're going to focus on. But I did want to bring that out, like what's the difference between a professional tool versus more of a do-it-yourselfer type tool. Okay, let's clear out these drawings and we'll keep moving forward. All right. So another way to look at the OEM tool, like the factory tool versus the generic tool. And again, it could be like the OEM side of your professional tool, the scanner icon versus the Obd2 icon. The OEM side versus the generic side is almost, think of it as like 2 different sides of the computer. Which I know it's all in the same computer, but think of it like maybe 2 different sides, definitely 2 different programs in the software. So in the OEM side, it's like I can do all kinds of stuff, but I'm at the manufacturer's discretion, right? So the manufacturer makes up the rules, and I can do whatever, I can do a lot of stuff, but it's whatever the heck they wanted me to do. And so I don't always have to play by the normal Obd2 rules. Versus on the Obd2 generic side, it says, hey, I can control the check engine light. I always play with the federal EPA regulations. I always have to play by the rules. So I can't lie to you as far as data is concerned. And there's lots of things that I can't do, but the things that I can do, I usually can do those things pretty well. So what we're really focusing on is this side of the computer's programming, right? The global Obd2 or generic Obd2 side. All right. So what are those mandated modes? What are those global Obd2 generic modes? Well, currently there's 10 modes. And on some tools, you will see it displayed just like you see it here, where they actually display it in hexadecimal language here. So you see these little dollar signs go up, and they don't say 10, they say mode 0A, which is our mode 10. So some of these things we've already been doing them, but some other ones we haven't. So tonight we're going to go through all these different things and really kind of flush them out and make sure we understand what's going on with those different mandated modes. Okay. Remember, you're not getting the most of your tool if you're only using it as a code reader, right? If you're only using it to read codes, all you're basically doing is mode 3 all the time. And that's just scratching the surface of what this tool can do, right? Okay, so again, just keep in mind that there are some advantages of generic OBD2, and namely that the data is a little bit more raw. It has to play by the rules, and one of the rules is you can't manipulate or substitute the data values on the generic side. Okay, they can do that on the manufacturer side. So I have here that technicians should always check back and forth between the global OBD2 side and then the manufacturer side. In fact, I like to check the global OBD2 side first and pull my codes from that and my freeze frames from that and look at some data from that, and then I'll go to the manufacturer side. Okay. Why do I do it that way? Well, you might find that there's some code stored in global that you can't find or see in the manufacturer mode. And so I'm calling the manufacturer mode the VIN specific mode, because on a lot of tools to get in that manufacturer side, you would actually have to put in the digits of the VIN number. Okay. So there might be code stored there that you can't see any other way. And sometimes you can't see the very first freeze frame unless you're in the global mode, right? So remember that in manufacturer side, it is really common for the PCM to substitute a good value for a bad sensor, and this is one of the tests that's kind of fun to do, like unplug a coolant temp sensor, or in this case, I have an intake air temperature sensor. You unplug it on your global OBD2 side, it'll go to 0 degrees or 40 degrees below zero. But a lot of times on a lot of cars on the manufacturer side, it's like the computer knows, oh, well, the air temperature couldn't have instantly gone from 85 degrees to -40. That's not plausible. So it will just keep showing 85 degrees on the scan tool. So anyways, I get why the computer's got to substitute a value so that the engine runs correctly. But then if it does that and it doesn't show you a change on the scan tool, you're likely to miss that problem. So there are advantages. And it was pretty common that I would go back and forth between the global side and the manufacturer side of my professional tool. All right, moving right along. So what will you have on your car? Well, the first thing is, it not only depends on what scan tool you have, right? Whether you have a do-it-yourselfer type scan tool or a professional tool, but also, well, what does the car have, right? What's programmed in the computer of the car? And that varies by how old or new the car is, on top of what tool you're using. So currently, if you had a newer car, well, it's kind of a mixed bag here, actually. I was going to say you get all 10 modes, but not necessarily. So it depends on the car, depends on your tool. All right. So what are these modes again? Well, modes, 1 through 9, I have displayed here on the screen. And actually, we've gone through modes 1 through 4, and we also looked at mode 7 before. And so this is pulling it back to our 8-step diagnostic process, where first we would verify the complaint, right? And for your typical scanner-driven type of diagnostic scenario, you're going to have a check engine light on, right? You're going to have a mill on. And so you verify, oh, yep, I have the mill on. The dude in the dash is not happy about something, right? So if the mill's on, I'm going to hook up my scan tool and I'm going to pull codes. So if we look at that, well, we've already talked about pulling codes. That's pretty basic. And if we look at that, well, what's pulling the fault codes? Oh, that's mode 3. So we've already kind of gone over that quite a bit. So then I said, hey, after you pull codes, you know, always look at your freeze frame data as well. And I said, don't just pull the codes, but also, you know, look for if there's any pending codes as well. So what that does is it brings in some other modes, like the pending codes, that's mode 7. And the freeze frame, well, that's mode 2. So we've already kind of gone over some scenarios where we would do mode, you know, 3, mode 2, mode 7, right? Then you look at the scan data. Does it support the code? Okay, well, that's really our mode 1 here is the scan data. Okay. And then we talked about, hey, now it's time at this point to look stuff up. We're going to do that more tonight in our pinpoint test. Then we talked about performing repairs and verifying those repairs by going back and checking for pending codes after we do our test drive. And that our test drive really needs to make sure that we meet the enable criteria to get these various monitors to run. All right, so what we haven't really gone into is some of these other ones, the mode 6, the mode 8, the mode 9. And so that's what I want to get into more tonight, because we've done the basics of pulling codes and yeah, looking at the data. Of course, we're still flushing out some of those data parameters, but I want to hit these other modes here. So moving right along. Okay, what do we have on the car scanner app specifically, and how does it line up? Because what you'll find is a lot of these cell phone based apps, they do a lot of the Obd2 modes. They may not do them all, but they'll do a lot of them, but they're not always titled like you saw on this screen. This is, I actually pulled this off of CDX, and some tools will list it out just exactly in the Obd2 hexadecimal numbering system, but a lot of tools, they won't make it look that way. Okay, so how, you know, the modes are there, but where exactly are they, right? So if we're looking for mode 1, the live data, well, I can get all the sensors right there, or from the other one that said live data, I could get, this one also would give me live scan data, but it would graph it. And this one just lists all the sensors. So both of those are mode 1. Okay. Also, this emissions test thing gives me a little bit of mode 1 data related to my emission monitors as well. Okay. But if I back this up, probably the most straightforward part of this would be to say, okay, well, that all sensors list, that's really like my mode 1 right there. Okay, mode 2 is going to be right there, right in the middle. There's my freeze frame. Okay, they put it really nicely right in the middle. And so, you know, right after I pull codes, my next pit stop always is going to be freeze frame. Now, of course, I got some other stuff on there. For instance, like mode 5, which is one we haven't really gone into, that there's nothing on the screen that says mode 5, but that's part of your non-continuous monitors. And kind of moving right along, mode 4, of course, that's pretty straightforward. That's right there, right? Where's my diagnostic trouble codes? also from right there is where I would go to clear my codes, right? So that's easily my mode 4. We've already done mode 5 is under this non-continuous monitors deal over here. But guess what? Mode 6, or say mode 5. Oops. Mode 6 is also in this non-continuous monitors. So my arrows didn't work exactly at the right angle that I wanted them to. So let's draw on this a little bit. All right, 5 and 6, they're both right here. Okay. Mode 7 with the pending codes, it's back under this DTC zone here. Okay. Then you got some stuff that quite frankly wouldn't be on a professional tool at all, right? So stuff like the dashboard, that's more for do-it-yourselfer stuff. The acceleration stuff, you wouldn't find that on a professional tool because the professional doesn't care about that stuff. But for the auto enthusiast, that stuff's kind of cool, all right? For example, this one that says dashboard, I like that one because I could put it up and like if I'm towing with my truck, I can monitor my transmission fluid temperature. I can use it as an extra set of gauges, which is pretty nice. Well, then it gets us to what about some of those other modes? I got 8, 9, and 0A, which is technically mode 10, right? What's the deal with those guys? Does this tool support them? This particular app doesn't really do modes 8 and 9 and 10, okay? And, you know, when I was doing this class, I was really hunting for a cell phone-based scan tool that did all the modes, and I couldn't find one that I thought was reasonable in price. There was some stuff that cost, you know, the app itself would cost like $40 or more that could do some more of the modes. But at the time that I was prepping our course, I couldn't find an app that did all the modes for a reasonable price. This Car Scanner Pro app will do all the modes. Well, it'll do everything except mode 6. So it'll do everything except mode 6 absolutely for free. And then if you want to do mode 6, the app costs $5. And it actually doesn't give you that much more. It takes away a banner ad along the bottom. And if you happen to have a Volkswagen, it has some nice features for that. But other than that, it's not fantastic. So the free app does modes, you know, 1, 2, 3, 4. It does mode 5, and it also does mode 7, and it does a pretty good job with those. I'll tell you what, guys, I'll put together an extra credit thing for you guys. If you guys can find a decent cell phone app that uses an ELM 327 protocol interface that doesn't cost an arm and a leg, like something that's maybe, you know, $15 maximum or something, that could do mode 8 and 9 and 10, I would be interested in seeing that. And actually, you know, I crossed out mode 10, but this Car Scanner Pro app, it very well may do mode 10. I just have not tried it on a car that's new enough to do mode 10, but more on mode 10 in a minute. Okay, moving right along. So let's talk about this mode 5. Well, mode 5, what does it do? Well, it provides you with test results on your oxygen sensors. In fact, it's pretty sweet. So how did the O2 sensors do on the last drive cycle? And it saves all these O2 test results up to 40 tests, and then it just kind of starts rewriting over that. But it's great if you're getting weird O2 sensor codes. it's a great way for you to see, well, what's the O2 sensor's performance over time? Now, it is a non-continuous test because the computer's not always able to test the oxygen sensors all the time. The enable criteria might be that, oh, I can only test the O2 sensor heater when the engine's cold and it's warming up. The O2 sensor response test might need you to be driving on the freeway at a steady speed to do that test, right? So this is definitely a non-continuous test. There's only certain times where I perfectly meet the enable criteria that it can test the oxygen sensors. On mode 5, that's where I can tap into some of that data. So here I have my old Snap-on scanner, my old red brick hooked up. You can see I went to O2 monitors right here. And then from there, I click the button and I get my next thing up. And then I can see this is the response time. So remember we were looking last week at a case study on the Suburban where we had some coding for O2 sensor, bank 1, sensor 1. And then it would code sometimes and other times it wouldn't. Well, here you can see the O2 sensor test results, and what you can see, the screen's cut off a little bit, but O2 sensor 1 definitely has a slower response time than sensor 2, right? Or not sensor 2, but sensor 1 on bank 2. So these are both the oxygen sensors in front of the catalytic converters. One's on one side of the V8 engine, the other's on the other side of the V8 engine, right? So we can definitely see from these test results that sensor 1 is running a little slower than sensor 2. By the way, what's the criteria? If you could scroll over on the screen, it didn't fit on my computer here, but if I scrolled over a little bit farther, what you would see is it says, what's the minimum time? What's the maximum time? 0. Do a little point there. 1, 0, 0 is the maximum time. So that's my max. And so you can see that this guy is really, really close to the max. Okay. So that's what mode 5 gives you. Okay. Here's the kicker. Mode 5, you're only going to find it on older cars, trucks, that type of thing. Mode 5 was pretty much phased out by about 2000, I want to say 7 or so. Why is that? Well, a lot of cars quit using oxygen sensors before the catalytic converters. They switched over to the air fuel ratio sensors. So that kind of, got rid of the necessity for that mode. And again, it's a non-continuous monitor. So on newer cars that do this stuff, they'll usually put this type of information in their mode 6 category and not mode 5. Okay. So that's why earlier I said, hey, a new car will do all 10 modes. No, it'll probably do everything except mode 5. All right. So mode 5, pretty cool. Gave me test results on what was going on with the oxygen sensors. It was pretty sweet. And it was a way, like, if I had a car that maybe the complaint was every once in a while it sets a check engine light, but then the check engine light goes away and it doesn't come back for quite a while. And I pull a code and I see that I do have a code and a freeze frame for an oxygen sensor. Or maybe I don't have a code, but I have a pending code or whatever. And so I can see, well, the light's not on right now. This lets me know how the O2 sensor was doing over time. So I can see that this one, hey, even if it's not failing right this moment, it's really close to failing. So it gives me the ability to kind of predict, okay, this thing's close to failing. Let's change it now. So pretty cool, pretty powerful there. All right, moving right along. By the way, some of that mode 5 stuff, you can tap into it under that non-continuous monitor function of the Car Scanner Pro app. Okay. So I could tap into some of that mode 5 right here. So it's kind of like mode 5 and mode 6 are both underneath that icon. Now, keep in mind that, you know, not every car is going to do everything that you want it to do. It depends on what's programmed inside this engine's computer here, right? Okay, so now we're on to mode 6. And again, mode 6 is request onboard system test results. And it's for test results for non-continuously monitored systems. These are things that you can't test all the time. Okay, so let me put together a couple of lists. I'm going to put one list together here in green. And my green list is going to be continuous. Continuous monitors. Now, what things should be continuous monitors? Well, I'm going to say all your sensors, meaning that like the computer should always be looking at sensors to see if they're shorted or opened. So I'm going to put in parentheses shorts, opens. Fuel trim. In that, in theory, the computer should be looking at the fuel trim all the time to see if it's too far out of whack. Misfire. In theory, the computer is always supposed to be looking for misfires and setting codes for misfires. But what we can say here is not really. Remember I talked about how if the car was really low on gas, it's going to turn off misfire monitor? Or if it thought you were driving over rough roads from erratic ABS wheel speed sensor signals, it would default to, you know, not running the misfire monitor. So like Ford puts their misfire monitor stuff under mode 6. So, but traditionally speaking, your continuous monitors, the things the computer's always looking for, is it's looking at all its sensors to see if something is shorted to ground or it's open. It's looking to see if the fuel trim is in line, and it's supposed to be looking for misfires all the time. Okay, things that are non-continuous. Well, I'm going to put those over here, and those non-continuous monitors would be things like I have on the screen right here. My cat monitor, EGR, Evap. Oops. Let's see. EGR, Evap, air injection. So a lot of your, I'm going to put in parentheses, your emission a lot of your emission control devices, right? So a good example is the catalytic converter I have up in this little drawing, this little animation here on the screen. So how does the computer normally monitor the catalytic converter? It's not like it's practical to have like a smog machine plugged into the car all the time, right? That would cost way too much money. So what we do is we have an O2 sensor in front of the catalytic converter. We have an O2 sensor in the back of the catalytic converter. And remember that the oxygen sensor, its job is to do just that. It's to measure oxygen. In fact, let me go back a slide here. And let's look at this picture. This picture right here, guys. Essentially, what this oxygen sensor is doing is he's comparing the amount of oxygen on the outside. So O2, O2, it's looking at how much oxygen is on the outside of the sensor. And it's comparing that to how much oxygen is inside this exhaust pipe here. All right. So if there's only a little bit of oxygen on the inside, but there's a lot of oxygen on the outside, well, because from that, it knows, hey, I'm running rich. But if it sees a lot of oxygen on the inside, closer to what it has on the outside, it says, oh, well, this is close to the same as this out here. So now I'm running lean. So that's what the O2 sensor does. All right. Well, if I clear that out, and I go back right here, what you can see is that the O2 sensor in front of the catalytic converter is getting these exhaust gases. Well, the O2 sensor in front of the catalytic converter should be cycling back and forth, rich, lean, rich, lean, rich, lean. But one kind of fancy thing about catalytic converters is, remember, the job of a catalytic converter is it gets real hot and it has a reaction on the inside. It has an oxidation reaction and it has a reduction reaction. And basically its job is to use whatever oxygen is in the exhaust stream and keep burning up those emissions. So the catalytic converter, by its nature, it's going to consume, or it's going to eat, oxygen. So it's going to absorb that oxygen as it continues to burn up the emissions, the hydrocarbons, the carbon monoxide that are in the exhaust gases. And so where I would get, you know, a more significant amount of oxygen before the catalytic converter, I should get relatively little oxygen behind it. And that's how the computer can tell if the oxygen, if the catalytic converter is working. So let me make this thing go forward. And so here I have another picture here. And so again, staying on the cat monitor, on a normal cat, what you would have is the sensor one, bank one, sensor one, that's the sensor before the catalytic converter. It's going to be switching back and forth. Rich, lean, rich, lean, rich, lean, rich, lean, rich, lean, back and forth. And what it does is it averages out the stoichiometric 14.7 to 1 air-fuel ratio. The one behind the catalytic converter, well, the cat's constantly absorbing the oxygen and then using that oxygen to burn up emissions. Oh, I got another puff of oxygen, absorb it, burn up the emissions. And so if your catalytic converter is good, it's absorbing that oxygen and using it to burn up emissions, and you end up with a relatively, once the cat warms up, a flat line on there. Now, if you goose the throttle real hard, you do a hard acceleration, decel, it's going to move, but it's not going to be jumping back and forth like the O2 sensor before the cat. So that's what the computer is looking for. This is good. Well, what's bad then? Well, if the front O2 sensor is bouncing back and forth, rich, lean, and then the rear O2 sensor is matching the front O2 sensor, like if both sensors look the same, the computer looks at that and goes, oh, well, I got a bad catalytic converter. But it can't test for this all the time. Because remember I said, if you're goosing the throttle, you're accelerating, decelerating, it's going to move with the throttle, right? So what's the enable criteria for a catalytic converter? What's the catalyst monitor? What does he need? He's usually going to need to see like 50, 60 miles an hour. And it needs to see that the throttle or the TPS is steady. Okay, because if the TPS is moving all around, it's not going to be able to get good readings on how this cat is. Okay, so it can't test the catalytic converter all the time. Hence, the cat monitor is a non-continuous monitor. So what the heck is mode 6 then? Well, mode 6 is the test results of this non-continuous monitor. Like, did the cat monitor pass its test? Well, I'll tell you what, if it set a code for the cat, which is a P0420 code, if it sets a catalyst code then guess what? It didn't pass the test. But what you get in mode 6 is the test results. So like, did it fail it by just getting like a, 49%, or did it fail it by getting an 11% grade, right? Like, how bad did it fail the test, or how weak did it pass the test? Did it pass the test and get like a D-, but it just barely passed? So kind of like the mode 5 would give you information on the oxygen sensors and allow you to kind of predict what was going on there. You could even look at something before it's failing and coding up and see that something's getting close to fail. Mode 6 will allow you to do that as well. Okay, so that's why I have here is, well, how bad can it be and still be okay, right? What's going on with this thing? If it passed, well, how well did it pass? If it failed, well, how poorly did it fail by, right? So look at this. Look at some of this mode 6 data off of our little scanner app here. You can see that I have a few things here that failed real bad, right? The minimum is 0, the maximum is 17, and what did we measure? 256, 512 for component 06, monitor ID 01. Here is the problem with mode 6 data, is that a lot of times the scanner isn't smart enough to decode what the monitor IDs are. So this monitor ID, that could be the catalyst monitor for bank 1, and this could be the catalyst monitor for bank 2. How do I know what it is? I don't know without doing some research. But if I have a professional tool or a factory tool where I programmed in that this is a Chevy truck or whatever, I program in the VIN number, well, then it can go to whatever's in its programming and decode what these things are and tell me what this is. It may not tell me what the value actually is, like it's 256 of what, right? It doesn't always tell you what it is, but at least you have your bearings and okay, well, what is this monitor 03? What is that thing? Is that the EGR valve? Is that the oxygen sensor? And so what you would have to do is look that up. But sometimes you can get lucky. Sometimes you can go into Google and you can say, okay, well, I'm looking for the mode 6 data on a Subaru, and it will tell you what the monitor IDs are, and then what the component IDs are. Now, sometimes instead of calling it a monitor ID, they call it a test ID, okay? So I used to say, well, what are the TIDs and what are the SIDs, right? What component is it and what's the monitor? So what I'll notice is that all three of these things are the same component, right? And then there's different tests. So I have 3 different tests here on the same component is what I got going on. So if that component is the catalytic converter, it's done 3 different tests on it and it ain't looking good, right? But I don't know what it is without decoding it. So mode 6 data can be really cool, but it can also be not so cool because you got to spend a lot of time looking stuff up. What the Scan Tool app has the ability to do, if you buy the Pro, like the $5, you pay $5 to get the Pro model, is on Volkswagen products. It can decode those TIDs and SIDs, or those component IDs and monitor IDs for you. Anyways, so now you know what mode 6 is. Lets you know how well it passed or how well it failed on a non-continuous monitor. On certain times, especially for like things like catalytic converters, it's nice to have, especially when you're trying to diagnose an emissions failure. Okay. Mode 8. Now, mode 8 is an example on an Obd2 car of what we call bi-directional controls. So I'm going to type up here, mode 8 equals bi-directional. meaning that the scan tool is going to control the car. Now, what two types of things do you typically have under mode 8? Well, you can see I got my Solus Ultra up here. And on mode 8, well, I can go on here and I can go mode 8. So I select this guy here, mode 8. And then from there, I have two choices that I could do. I can do an Evap leak test. So this would be like on a gasoline car. Or if I was on a newer diesel car, I might be able to do diesel filter regen, okay, meaning it's cleaning the DPF filter. I've never had one where the DPF thing worked, but I have had a few cars that the Evap monitor would work. Now, let's take a couple steps back. What is Evap monitor? Well, I don't know if you've ever had like a can of gas sitting in the sun. What you notice is that can of gas will really swell way up when you let that thing sit in the sun. All right. Here's my gas in the can. And of course, when it's sitting in the sun, the gas begins to evaporate and the plastic gas tank starts blowing up and it starts expanding. That happens in the gas tank in your car as well. We don't want to just let these vapors come out of our gas tank and float into the air. These vapors are hydrocarbons. They form photochemical smog. They're not good. And hey, you're wasting gas, right? So cars since the 1970s have been designed to collect these hydrocarbon vapors, these unburnt gasoline vapors. They've been designed to collect them and store them in a charcoal canister and then burn them later on when the engine's running, okay? Well, starting with Obd2, they said, hey, we should check to make sure that system's not leaking. And so 96 and newer cars, for the most part, I mean, before 98, they was pretty spotty. But anyways, the idea is that the Obd2 cars were actively testing their Evap systems to make sure that they didn't have leaks. And so there's all kinds of Evap leak codes like Evap 456, which is the start of a bad day, and Evap 440 codes. So this is a mode where you can put the scanner in an Evap test mode to force it to run the Evap monitor and test the system for leaks, okay? So that allows you to do manually command an Evap test. This is not something that our app can do, but it is something that you could do on a more professional tool under Obd2 generic modes, as long as the car was smart enough to do it, right? Because the other part of that equation is the computer in the car sophisticated enough to allow the scanner to control it and do that Evap leak test, okay? So that's mode 8, request of control of onboard systems. It's bi-directional controls in generic Obd2. All right, moving right along. Mode 9, request vehicle information. I find this one to be a very powerful one, especially with my students. With some of you guys, you're piecing stuff together. You got project cars. You're grabbing computers out of the wrecking yards. I have other students that are reprogramming their cars and then they're running weird. And this allows me to read information about the vehicle, okay? So mode 9 is request for vehicle information, okay? It allows you to look at what is the VIN number. So here I'm selecting mode 9, read vehicle information, and you can see on my Solus Ultra, I can look at what the VIN number is. I can look up what the ECM calibration number for that VIN is, or the cal ID, and then the verification. I got some serial numbers that I could possibly pull. So it's like the vehicle's fingerprint as to what's going on. And I've had this, save my bacon a number of times. One of the most recent times is I had a student and he had a car that he was working on. He just couldn't get it to run right. And he thought, man, it had a bad computer in it, but I replaced the computer and it's still running bad. And well, it turns out, you know, what I finally did is I went to mode 9, and the VIN number here did not match the VIN number on the car. And we start looking through here and we realize, oh, well, that he got that computer out of pick and pull, and then that computer came, you know, it was powering a V6 engined car, and he's got it in a V8. Well, it doesn't have fuel injector drivers for the other 2 cylinders. So no wonder it's only running on 6 cylinders. He's got the wrong computer in there. I've had other cases where I had cars that were failing for smog, and it's because somebody, you know, it's like, I can't find any bad parts on this car. Well, the bad part is that they reprogrammed the computer, and now it's giving it too much spark advance and not enough EGR flow, and it's failing for oxides and nitrogen. So I have found mode 9 to be very, very powerful, so that you know that you actually have the right stuff, the right programming and the right computer in the vehicle. This, by the way, is one of the modes that the smog machine checks. So if you have reprogrammed your car to set all the monitors and never turn on the check engine light, when the smog machine talks to your car, if your car supports mode 9, this is where the smog machine would go in. It would pull this information and see, oh, this guy's reprogrammed the car, and that could cause you to fail a smog test. Or what it could do is just flag your car in the vehicle information database that the bar has. So anyways, mode 9, pretty powerful mode. Lets you know what's going on there. But you can see why if you were building a scan tool that's really for do-it-yourselfers, maybe that's not something that you would need, because the do-it-yourselfers should know, you know, the idea is that they're not doing that type of stuff, changing computers and stuff. So anyways, that's what mode 9 is all about. Now, mode 10 is a little different, right? Now, it might be displayed as mode 0A, but I like to call it mode 10. Now, mode 10 really started coming about in model year 2010 in newer cars, and it kind of phased in. It was like 50% of the 2010s would have mode 10, and then a couple years later, 75%, and by now, all new cars should support mode 10, okay? Now, what's mode 10? Mode 10 is permanent codes, meaning that they're not going to be able to be cleared by your scan tool, okay? What's weird about mode 10 is that the check engine light may not be on, okay? But it might have some mode 10 codes in there anyways. And so unless you check for mode 10 codes, you might not realize that they're there. Well, guess what, guys? The smog machine checks for mode 10, and that's what really mode 10 is all about. So let me keep this thing moving forward. So why did mode 10 come about? Because over that 10-year period of us looking at cars that were OBD2, what the Bureau of Automotive Repair through the smog check program and various states that have their own smog check programs, what they began to realize was that, oh, well, you know what? People are kind of sneaking cars through, okay? And they wanted to stop that from happening. So mode 10 stands for Permanent Diagnostic Trouble Codes, or PDTCs, and it's a code that ends up getting stored in the NVRAM. Well, the NVRAM, that stands for non-volatile random access memory, okay? That means that I can't clear it with my scan tool, and I can't clear it by disconnecting the battery. It's in there. Does that mean it's in there permanently? No. But the only way to get it out of there is to actually fix the car and to drive it out. Okay, so it's not really permanent, but you can't clear it with your scan tool. You can't clear it by disconnecting the battery. You got to drive it out. Why did they do this? Well, if you look at the Obd testing rules right here, what you can see is if you have a 96 to 99 or even a 2000 newer car you can have any one monitor be incomplete, and it will still pass the smog test. On the 2000 and newer, the Evap monitor, the one that checks for any leaks in your gas tank or any of those little lines, it cannot be complete and it'll still pass the smog test. And so what people figured out is they're like, oh, you know what? I have an Evap code. Okay, I have a, let me advance this thing one slide, because here's a good example of a car that's failed its smog test, and it's failed it due to a permanent DTC. What's the DTC? P0456, evap leak very small. Okay, like I said, that's the start of a bad day. How small is very small? It's less than a 10,000th of an inch leak. Yeah, it's super small. It's a pain in the butt to find. Some of these 456 codes will drive you absolutely nuts. So what, guys figured out, and it could be professionals, it could be do-it-yourselfers. People figured out that, oh, if I had a code like this, that's a pain in the butt. And after a while of messing around with it, they said, oh, the heck with that. You know what I'm going to do? I'm going to take my scanner and I'm going to clear all my codes with my scanner. Then I'm going to drive it around just enough where it runs all the monitors except for the Evap monitor. And then I'm going to take it over to the smog shop and gun it through, right? And if I time it just right, it will pass the smog test because the Evap system hasn't ran, and so it hasn't set the very small leak code yet, and it will pass the test and I'm good. And they basically kept seeing a pattern where that would happen over and over and over again. And so they worked with the car manufacturers and they said, well, hey, let's set up this permanent DTC thing, and then that will stop that from happening. Because if it sets a code like that, you're not going to be able to like clear it and gun the car through and time it just right where before the code sets, but you've driven it just enough to run the other monitors. And that's really what it's all about. So kind of a pain in the neck, huh, guys? But you get the idea. And so again, if it had a permanent DTC, the check engine light could be off. Why? Because you went in there and cleared the codes with your scan tool. So the check engine light's off, but it's still storing a permanent DTC, because the only way to get this thing out of there is to get it to run that monitor multiple times in a row and get it to pass that monitor, right? So if you haven't driven it enough to have it run that monitor, meet that enable criteria, get it to run that trip and test it and be A-OK, that code's going to stay in memory and it's going to end up failing the smog test. Well, will it always fail the smog test? No, it won't always fail the smog test. They realized when they started doing this, they realized, oh man, everything's failing. So they had to create some wiggle room, because some drivers, they just might not ever drive the car how it needs to be driven to get it to meet the enable criteria, to run the monitor so that it will pass, so that it will clear the permanent DTC. And of course, if the technician cleared the codes, the check engine light's on, so the customer doesn't even know that that permanent DTC is in there anyways, right? Customer doesn't know what's going on. Because remember, what happens is you're driving down the road, the Obd2 system would run a monitor, it would meet enable criteria, it would run a monitor. If it failed that monitor, it would set a code, right? Our example is that evap leak that's super small, right? And that could have been set. I mean, usually if you leave your gas cap loose, it's a evap, it's like a 440, it's an evap leak large code. But anyways, you could have a little tiny crack in a gas cap or something. So it sets that port 456 code. In the RAM turns on the check engine light. You go in there and clear it. But you know what it also does is it throws it in that non-volatile RAM. And the only way to get it out of there is to meet the enable criteria, get it to clear itself out. So that means you really have to fix the problem and you got to drive the car and the car has to be driven to meet the enable criteria. Well, knowing that some people are bozos, they're never going to meet the enable criteria, the compromise that the Bureau of Automotive Repair came up for our smog check program is they said, hey, okay, here's what we'll do. If you've driven at least 15 warm-up cycles and gone about 200 miles, even if that permanent DTC is not cleared, you've driven it enough where we're going to not worry about it at this point. Because maybe that particular car is just a real pain in the neck to get it to meet the enable criteria and run that monitor. And so they don't worry about it. If it's gone for 200 miles, 15 warm-up cycles, they don't worry about it. But what usually happens with a permanent DTC, and what I would recommend, is if you're working on a car that has permanent DTC set, make sure you charge for extra time. Charge extra time so that you can actually drive this car through its drive cycle. It might need a warm-up cycle. It might need you to get up to 35 miles an hour and then go up to 55 for 5 minutes and then slowly decel and do some, accelerations. I mean, who knows? You're going to have to go through some special steps to meet the enable criteria to get that monitor to run. I would charge extra money for dealing with permanent DTCs so that you can get them cleared out for the customer. Because if you don't do that and they think, oh, you say, hey, just go drive your car. And maybe they throw 100 miles on the car and they've done, I don't know, 10 warm-up cycles. Well, guess what? They think they've driven it enough. They can't tell that the code's not cleared and it's going to fail for smog. So anyways, that is what mode 10 is all about. And it's on 2010 and newer cars. Can our scan tool cell phone app do mode 10? Honestly, I'm not sure because I haven't used it on a car that's that new. So that's something that if you guys have a car that's newer than 2010, I would love for you to check that out. Now, remember, not every 2010 will support mode 10. 50% of the California certified cars supported mode 10. Then it went up to like 75. And so really, if you got a car that's about 2015 or newer, or a truck that's gas that's 2015 or newer, that thing is new enough where it should absolutely support mode 10. So if you got a car that new, try to scan it and see if there's anything in there. Of course, if there's nothing wrong with the car, it probably won't set a permanent, it probably won't have any permanent TTCs in there. But anyways, so now we've gone through the 10 modes of OBD2, and there is some conclusions here. Okay, the thing I want you guys to realize is that cars have evolved a lot since OBD2 came into being. Okay, I grabbed two pictures of a Camry, a new Camry versus a Camry from 1996, the first year of OBD2, and look how different those two cars are. Right, they're dramatically different on the technology that's under the hood of each one of those cars. So the cars have evolved, so have our tools as well, right? And there's obviously a big difference between a professional scan tool and a do-it-yourself scan tool, okay? But with that being said, I really do feel like there's a lot that you can do just focusing on modes 1 through 4, and I should have added in mode 7 there, that we can get with our scan tool app. There's still a lot of diagnosis that you can do, and so our goal is to get you to maximize those modes of the tool. And I always like to say, a smart tech can do way more with any tool that he or she has. So whether they have that inexpensive do-it-yourselfer tool, or they have that professional tool, they can do way more with that tool. So now we know about all the OBD2 modes, and I don't want you to be disappointed or upset that maybe your tool doesn't do them all. There's still a lot of diagnosis that you can do with the basic modes of OBD2 if you're using all your brain power. And that's going to be That's going to be our goal there. So I'm going to switch our screen share back to the internet, and I'm going to close out that presentation. And I need to wrap this thing up because we're going a little bit over time, and I don't want to be putting you guys to sleep. But I promised you that I would wrap things up with doing a diagnostic on one of your cars. So it was supposed to be a discussion when I made this thing, and what you can see is it's not on there as far as the discussions. If I go here to assignments, it's there because I made it an assignment, not a discussion, even though I thought it was a discussion. So it was, what diagnostics do you need? Okay. And so I said, like, in this discussion, but all right. So the idea with this is if you had a car that had something wrong with it, get me some information. Your make, model, what's the complaint, what's going on with this thing, and let's figure it out. So Alex, thank you very much. Alex did this exact thing, and I wanted to talk about it last week, and I forgot. So Alex, we're looking at your car tonight, and we're going to see what's going on here. So we have a Camry 2001. It's got the classic 3-liter V6 in there, and it's set in a P1130 code. And you're right, it's probably an oxygen sensor. You got your VP tool, and you got me some screenshots of the freeze frame data, which is awesome to look at there. So we can see we set that code. When we set that code, we were at 50% load. The engine was at 56 degrees C, so it wasn't fully hot, but it wasn't fully cold either, right? It was just kind of starting to warm up a little bit. And a couple things jump out to me on this freeze frame. And so let me highlight those. I noticed that the short-term fuel trim, boom, really high, 19%. So I've pretty much maxed out, or I'm getting close to maxing out short-term fuel trim, meaning that it's having to add fuel to bank one. Now, that can either be because bank one is really running lean and it's having to add fuel because it really is running lean, or just like you said, Alex, if the O2 sensor is defective, how they usually fail is they just say they're lean all the time. They don't fail at a high range. They usually fail at a low range. And the way these things work, usually low is lean. Okay. So we can see that bank one's looking terrible. Bank two's looking okay, right? It's a V6 engine. So we got two banks. We can see that the code was set at just over 2000 RPM. And, we weren't going down the road very fast here when it happened. So, it was kind of warming up. You're just getting going. Boom, sets the code. All right. So we got the code. We got the freeze frame, and that is excellent stuff. So then we start looking at some data here. And some things do pop up to me on this data. So example, engine coolant temperature at 74 degrees Celsius. So that's getting pretty hot. That's nearing, normal operating temperature. We can see that the short-term fuel trim, it's adding a lot there. Mass airflow, sensor rate, intake air temperature. What I want to see, okay, bank one, sensor two is at 0.7 volts. I want to see what my bank 1, sensor 1. Okay, here we go. So this is what's kind of interesting right here. Sensor 1, and it says 3.3 volts. Sensor 1, 3.3 volts. Okay, fuel air equivalence ratio. And so what I'm going to say is, looking at those readings, I think what this vehicle has is not an oxygen sensor, but it's got an air fuel ratio sensor ahead of the catalytic converter. And then behind the catalytic converter, it's got oxygen sensors for catalyst monitoring. And, you know, Toyota switched over to air fuel ratio sensors, AF sensors. Think of it as like an oxygen sensor on steroids. Toyota switched to AF sensors in the late 90s, early 2000s. So time-wise, that would be correct. So that's what really stood out to me. You know, it's hard to tell because we can't see the data move from these screenshots. But how these sensors work is their normal voltage is 3.3 volts. And then if you drive the mixture rich, I want to say the voltage drops down. And if you drive it lean, the voltage goes up. And that could be vice versa. But in any case, I think we got an air fuel ratio sensor. Those do run twice as hot as an oxygen sensor. They do have a tendency to burn out. So it doesn't, you know, it does make sense that that would be the failure. But let's look up some more service information on this thing. So here's what we're going to do. We're going to switch our screen share over to ShopKey Pro. What you guys can see is I've already dialed in the Toyota Camry. And I typed in the search box the P1130 code, right? That's a manufacturer specific code. So now I'm going to go over here to OEM testing and look, just like I thought, air fuel ratio sensor circuit range performance. Okay. And what it was is, in the early 2000s, Obd2 generic, they hadn't come up with codes for air fuel ratio sensors yet, but the manufacturers were already putting them on the cars. And so that's why this is a manufacturer specific code. So under the description, this is really good. This is where it tells you how it works. In fact, you know that assignment we were looking at tonight where you have to write down a data PID and tell us the range? This is a great place to get that type of information. So it gives you the description. It says it looks at the exhaust oxygen content. It's going to set that code for the number 1 air fuel ratio sensor. So that's going to be for bank 1. And then this other guy is for bank 2. So what you can do as far as your data is you can compare the air fuel ratio sensor bank 1 and air fuel ratio sensor bank 2. You can compare those two under live data. And what I would do is I would try to run the car rich, and I would try to run it lean. Okay. Well, without a propane tool or some carburetor cleaner, it's hard to get it to run rich, but it's pretty easy to get it to run lean. What you can do is take off some vacuum hoses while it's idling and make a vacuum leak. That's going to force it to run lean, and you should see both of those sensors, that their normal range is 3.3 volts. You should see them move. In fact, if we go down here, it says using the Toyota handheld tester. You know what that is? That's the Toyota factory scanner is what they're talking about. So they're saying, hey, use the Toyota factory scanner. And they say during enrichment, so making it run richer, the voltage is going to go down to 2.8. During fuel cut, which means I'm making it go lean, it's going to go to 3.8, right? So let me highlight that. It's going to go to 3.8. So it tells me the range. So it's just like I said, it's when the voltage goes up, it's actually going lean. It's the opposite of a normal oxygen sensor. So I'd pull some vacuum lines and I'd make it run lean and see if the voltage went up for both bank 1 and bank 2 when I went lean. And if bank 2 responds, but bank 1 doesn't respond, it's more than likely the sensor, right? But it says what else things, oh, the circuit could be open or shorted. The sensor could be defective. And I totally agree with you. This is the most likely one. I could have a problem with EGR or improper fuel pressure or any of these other things. However, fuel pressure, you know what? That would affect both bank 1 and it would affect bank 2. So you know what? I'm gonna get rid of him. A defective fuel injector could cause it if the fuel injector was one of the bank 1 injectors. Obviously an ECM, but that's not very likely. The most likely thing on here, honestly, is going to be this. And so I would drive it lean. I'd see if it responds. If it doesn't respond, then I know I have an issue with the sensor or its circuit, right? And so my last thing would be to get out my meter and to use my meter and test the wires on there. So let me clear out these scribbles. Now I'm into pinpoint testing mode, right? So it's got my test drive, like that's where after I do my repair, right? After you throw a sensor on it or whatever. But what I need to do is go back here. No. Really want a, no. This is common problems and causes and fixes. That's kind of helpful. Here's what we're going to do. Now we're going to go air fuel sensor wiring diagram. Okay. Let's just go wiring diagrams. All right, let's just click the wiring diagrams thing, go to system. We're going to go to power distribution, engine performance. There we go. 3 liter. This is going to get a little ugly, but I'm going to scroll through here until I find that. Okay. And that actually wasn't too bad. Okay. So air fuel sensor, bank 1, sensor 1. There it is right there. And what I can see is here's the various wires to it. Red, black, there's the black. So I've highlighted those wires. Now what I can do is start going through there. I can see that this wire here goes to the air fuel sensor heater relay. And so I should have 12 volts coming on here, right? And so basically what you would do is make sure that you have voltage where you're supposed to have voltage, that you have ground where you're supposed to have a ground, that the signal wires are intact and everything. And if all that is the case, then yeah, your problem has to be the sensor. Now, those sensors on those model year cars actually have a pretty high failure rate. And the reason is that where a normal oxygen sensor would run at 600 degrees Fahrenheit, air fuel ratio sensors, they're almost like an O2 sensor in an O2 sensor. So they run at 1200 degrees Fahrenheit. And it's like they just burn themselves out. In fact, on some of the cars, like the RAV4s were notorious for this, they would get so hot, they would like get welded into the exhaust manifold. And you couldn't get them out without changing the entire exhaust manifold, okay? So yeah, most likely it is a sensor that's your failure. And be prepared that it might be a real booger to get it out of there. And in some cases, you got to go in and replace the whole exhaust manifold because you just can't get the sucker out. But run it rich, run it lean, look for it to respond. If it doesn't respond, then you know it's the sensor or its circuit. Test the circuit with your meter. If the circuit checks out, then you know for a fact that it's got to be the sensor. Once you put a new sensor on, of course, run through your drive cycle or your trip to meet the enable criteria to make sure that everything tests out a-okay. So hopefully that gets you going the right direction. And I appreciate you putting this assignment. That's a good one. It's a little hard to do like without looking at the data and watching it move around. But I feel like we got a good direction on that diagnostic. So, all right. Well, that is going to wrap us up for tonight, guys. I'm going to switch this thing back over to the home screen. Again, you have a couple of things due, and those consist of a little quiz and this activity of getting used to normal data, where you pick one data parameter and you write down, well, like, what should it be at a cold startup? What should it be at a hot idle? What should it be when you're normally driving the car around? And ultimately, what type of range does this thing have? So you kind of get to learn, get you digging into the data so you learn what normal looks like. So for this example, you could pick an air fuel ratio sensor. And what would I say? Well, you know, I would say at hot idle, right, it's supposed to be somewhere around 3.3 volts. And at cold startup, I think it's also supposed to be 3.3 volts. I'd have to read that chart again. And then it's under normal driving conditions, it's going to vary from a little bit above 3.3 to a little bit below 3.3. And what would the range be? Well, like full lean was 3.5 or something. I don't know. And then full rich went down to 2.8. I'd have to go back to that screen. Anyways, so you know, you could do that activity on an air fuel ratio sensor. That would be a good one to put on there. And also an oxygen sensor, fuel trim. Where we're going to go on this thing next week is we're going to be talking about setting a custom data list and really diving into the data, doing some more diagnostics with the custom data list. And then we're going to go from there into O2 sensors and fuel trims and some neat things that we can do with basic data, like our volumetric efficiency calculators. That's going to be kind of like our grand finale for the class. So anyways, I look forward to seeing you guys next week. We'll also be on Confer Zoom again, just like we were tonight, and I'll try to make it a little bit shorter lecture. I apologize for this one taking a little bit longer than I wanted it to, but I had a lot of great stuff to get over. So I hope you guys got something out of it. And with that, I probably burned you out. I don't see any questions coming up on the chat. So I'm going to say, have a great rest of your night. Sorry for talking too long, and we'll look forward to seeing you guys next week. Okay. Bye, everybody.